Hello, I'm Dr. Michael Riddle Jr. I'm a lifelong inventor with a passion for solving problems and filling needs. Many people have great ideas, but never end up bringing their ideas from concept to reality because of a lack of motivation and drive and sometimes other factors. I, on the other hand, was raised to do whatever it takes to get the job done, and that doing what is worthwhile is never easy. I would like to share with you a couple of projects that I've worked on that demonstrate my ability to bring my ideas from concept to reality, and also demonstrate my ability to work with a team to get the most out of a project. When I was a medical student at UTMB, I saw an opportunity to work in the regenerative medicine laboratory, where I heard that they were working with stem cells to grow working lungs. While working in the lab, I observed that they were working with mouse and rat lungs and were able to grow a functioning lung using stem cells and a bioscaffold, which is just a cadaver organ with the cells washed off, leaving the cellular scaffold behind. I then went to Dr. Nichols, the co-director of the program, and inquired as to why they were not scaling the project up to large animal and human lungs. Dr. Nichols responded that it took them 5 months to manually decellularize a pig lung, and that there was not a bioreactor big enough to grow a large lung. I saw this need for a large lung bioreactor as an opportunity of a lifetime. Much to my wife's chagrin, I took our grocery money and went and purchased the supplies to make the first large lung bioreactor in my brother's garage workshop. I used the time off during the long Labor Day weekend to build the first prototype. I used a fish tank purchased from a pet store, cutting board plastic that I purchased from a boat supply store, and pump heads, stepper motors, and other various electronics that I bought off of eBay. To make a long story short, I was able to take the 5-month manual decellularization process of a large lung down to only 38 hours using an automated process in my bioreactor that I designed and built. I came up with a unique design for my bioreactor that suspended the lung upside down in the decell solution or the media that allowed for perfect support of the lungs with no vascular compression whatsoever. This ideal support allowed for perfect perfusion of the decellularization fluid and later for the cell suspension in the media. I ended up selling the rights to my lung bioreactor design to Harvard Apparatus and kept the rights to continue to develop the lung bioreactor technology while at UTMB. I continue to collaborate with UTMB with the lung project. We published our first paper on the large lung project in Tissue Engineering, and our second paper, that I'm also a co-author on, is going to be published in Nature. My team at UTMB was the first to grow a functioning human lung in the laboratory. Harvard Apparatus also contracted me to design and develop a bioreactor to condition heart valves that have been decellularized and then recellularized to allow the cells to differentiate properly. The bioreactor I designed places the same stresses on the heart valve as it would see as if it was attached to the heart inside the body. I also participated in the development of the software and hardware that Harvard Apparatus currently uses on all of its current bioreactors, that's based off a hardware-software platform from National Instruments. My heart valve bioreactor is now being used at the Mayo Clinic in Rochester, Minnesota. I have a variety of other inventions and products that I have developed and sold over the years as well that include a necklace pendant that contains a large amount of emergency information on an easy-to-read magnifying pendant. I also developed a bed that supports patients by over 600 pneumatic actuators. This special bed was designed with a custom program to support patients with pressure ulcers and burns. Many of my inventions were just devices to assist me with my job in the laboratory. I started a for-profit research laboratory last year to bring my innovations in regenerative medicine to the market. I currently produce a stem cell factor-based wound spray for horses that I developed and a few other stem cell-based products. My wound spray filled a need in the horse industry for a wound treatment that was easy to use, prevents proud flesh, and helps the wound heal with minimal or no scarring. The vets that have tried the wound spray have been impressed with the reduced healing time and the improved aesthetics of the healed wound after using the spray. Many of these vets now keep the spray in stock and consistently give me good feedback. To date, we've not yet had any adverse reactions from horses using my spray. So in my spare time, I enjoy tinkering with things and restoring vintage medical equipment. The latest project I completed was a 1959 Emerson iron lung. After completing the restoration, I ended up using it for a proof of concept to make a negative pressure ventilating incubator. I used the iron lung as the negative pressure oscillating pump. I now leave you with a moment of zen.